Okay, the second part of the chapter is the sampling distribution for the proportion. We already covered sampling distribution for the mean, right? Now it's sampling distribution for the proportion. We already saw what is a proportion, right? A proportion is nothing but a fraction or the part of the elements with a particular characteristic. Okay? So let's say that I have 100 students and 45 of those students are females. So I'm saying that 0.45 is the proportion of the students that are females. Okay? So P is basically X divided by N. Now, since we have the sampling distribution, we know that we have a population and we have a sample, right? From the population, we have parameters. What are the parameters of the population? Mu, sigma, and pi is the proportion of the population. For the sample, we have the statistics. These are the parameters. For the sample, we have statistics. What are the statistics? X bar, S, and P. Okay? Sometimes some books call it this P and this P bar, but you know, it really doesn't matter. It means what is, I like it pi better. Why? Because it's a Greek letter. So whenever you see a Greek letter, you know that they belong to the population because they are parameters. When you don't see them, they belong to the statistics as a sample. Now, remember when we covered that the binomial distribution can be used, or the normal distribution can be used to calculate the binomial distribution. So this is really a binomial distribution. The elements, whether they have or not have the certain characteristics. Now, when can we use the normal distribution for the proportion? When NP is greater than 5 and NQ is greater than 5. So what is Q? Guys, someone asked me this during the test. Q is 1 minus P. Okay? When both of these are greater than 5, we can consider that this is normally distributed. Remember about the central limit theorem that says that when the sample size is big enough, no matter what the parent distribution is, the sampling distribution is normally distributed. Okay? Now, in this case, when NP is greater than 5 and NQ is greater than 5, and, not or, and NQ is greater than 5, then we have a normally distributed distribution with the mean equal to what? To the proportion of the population pi, and the standard distribution is equal to the square root of pi times 1 minus pi divided by n. Okay? And then you have everything else. I mean, that's it. We have a normal distribution with the mean is equal to pi. And what is pi? Pi is the proportion of the population. And the standard distribution equals to pi times 1 minus pi divided by n, square root. What is n? N is the sample size. Why? Because we are sampling. Remember, these are sampling distributions. In this case, so the standard distribution of P is pi times 1 minus pi divided by n, right? This is the standard deviation of the resulted distribution. What if we are dealing with a finite population and the sample size is greater than 5% of the total population? Then we need exactly the way we did for the sampling distribution of the mean. We have to include the n minus n divided by n minus 1 only if the sample size is greater than 5% of the total population. Okay? So it's exactly like we did in the sampling distribution of the mean. We need to include the finite population correction factor only when your sample size is greater than 5% of the total population. How do you know that? If n divided by n is greater than 0.45, then you use the finite population correction factor. Otherwise, you don't use it. So it's exactly the same. That's it. That's the sampling distribution for the proportion. Let's do an example. Any question? Let's do an example. I don't know if this is 732. I don't know why. 732 is not part of the homework. I'm sorry for that, but let's do 732. 732 says the social media and personal responsibility survey in 2010 found that 69% of parents are friends with their children on Facebook. Okay? So 69%. What is 69%? That's the proportion. Okay? So what is pi? Pi is 0.69. A random sample of 140 parents were selected. What is 140? N is 140. That's it. That's the only two things that you need, the sample size and the population proportion. Calculate the standard error of the proportion. Well, okay. We did cover this when we were dealing with the mean. This is the standard error. The standard distribution is also called the standard error because remember that the standard error is how far away the real parameter is. So the standard error of the proportion is nothing but what? The standard error of the proportion. So the standard deviation of the resultant distribution. Okay, that's it. That's equal to pi times 1 minus pi divided by n. That's equal to 0.69 times 0.31 divided by 140, the square root. And that's equal to 0.69 times 0.31 divided by 140, square root, is equal to 0.0391. 03908, so 0391. Okay? So we know that the resulting distribution or sampling distribution for the proportion is normally distributed with the mean equal to what? To pi. What is pi? 0.69. And sigma equal to what? 0.0391. So This is the resulting sampling distribution when we sample this particular population. Okay, do we have a finite or infinite population? We have an infinite population. Why? Because they don't give us the population size. So we have to assume that we don't have to use the finite population correction factor. Okay? And again, let me tell you, when we use the central limit theorem, it says that when the sample size is big enough, the resulting distribution is normally distributed. However, when the sample size is not big enough, if we want to use that assumption, we have to assume that the population is normally distributed. Okay? Some of your examples or your book says, what are the assumptions that you need to consider? Since the sample size is not big enough, then you have to assume that the population was normally distributed. Okay, B, what is the probability that more than 100 parents from this sample are friends with the children's? What is the probability that more than 100? Okay, so the proportion has to be more than 100 over 140. So P is equal to X divided by N. So X is 100 divided by 140. And that is equal 100 divided by 140, 0.714. Whatever, 100 divided by 140. So the problem is asking me, what is the probability on this distribution that the proportion is 0.7143 and beyond, or bigger? So we have a standard distribution with the mean is 0.69 and sigma equal to 0.0391. And I want to know what is this probability, where this number over here is 0.7143. So you learned that in the previous chapter. So you need to convert this. Guys, there is one way to do this in your calculator without transferring into a standard normal distribution with the mean equal to 0 and sigma equal to 1. However, so this is Z, this is X or whatever, so Z is equal to X minus mu divided by sigma. So my Z over here, I'm looking this value such that what? This area over here is exactly this area over here. Okay? What is this value? That's X is 0.7143 minus mu, that is 0.69 divided by sigma, and sigma is 0.0391, and that value is equal to, just put it in the calculator, 0.7143 minus 0.69 divided by 0.0391, and that value is 0.62. So this one is 0.62. What I'm saying is the probability that this proportion is greater than 0.7140 is exactly that the probability that the Z is greater than 0.62. You go to the tables or you go to the calculators and you have that probability, and that probability is going to give you what? What we are looking for. What is the probability that 100 or more of the parents are friends with their kids in Facebook? You see? And that is what? 0.2676. So that the probability that we have that one is this one. And that's exactly the same, it's 0.2676. So that is the probability. I don't know if I'm going to see. What is the probability that between 96 and 105? It's exactly the same. What is the probability at 96 and 105? So what is the probability? What are the proportions? Just divided by 140. 96 divided by 140, that's equal to 0.6857. And 105 divided by 140, 0.75. C is asking you what is the probability, and again, guys, please draw the problem so you see the problem. Sometimes in your test, you didn't draw the problem and you just missed everything. Draw it. I mean, I do it every time that so this is 0.69 and this is sigma is equal to 0.03 what? 91. And the problem asking what is the probability that between 68, 0.68, 57, and 0.75. What is this probability? You can do it directly with your TI-84. I don't want to put TI-85. And so you turn it on, then go to distributions, go to normal distribution, normal CDF, cumulative distribution function, hit enter, and you are going to enter the interval. So you have to enter 0.6857, comma, 0.75, and if you hit enter right now, it's going to be assumed that it's a normal distributed, standard normal distribution for the calculator. But you can, enter the mean that is 0.69 and comma, and then enter the standard deviation that is 0.0391, hit enter, and the probability, this probability is equal to 0.4830. Okay, so there is a way that you can do it using the TI-84 by entering the range, the mean, and the standard deviation. Instead of, translating this, it doesn't matter what the way you use. It's up to you. You use the way that you feel more comfortable with. Or you can use, translating this value into a standard normal distribution and then to what you already know. And that is going to give you exactly the same results. Okay?
Did you say it was CDF?
Yeah, cumulative. Cumulative. Yeah. When you go to bars, you see normal PDF and normal CDF. The C is for cumulative. And cumulative means the PDF gives you the height of the distribution, which we don't use. Okay? But the cumulative distribution gives you probabilities from this point to this point. And that is why when I ask you to use the TI-84 to calculate normal distributions, the negative minus infinite could be minus 20 or something, and the positive is 20.
So what was the numbers you put in, the 0.6857?
I entered normal CDF, and I entered first the interval 0.6857, comma, the upper range of the interval 0.75, comma, then I enter the mean, that is 0.69, comma, and then enter the standard deviation 0.0391, and hit enter, and the calculator gives you 0.48, whatever it is. Okay? I mean, it really doesn't matter if you use a calculator or you use the translation between this distribution to a standard normal distribution. That's it. Yes.
If you wanted to use the calculator on this one on the right, would you just put in,
Exactly the same thing.
you don't have an upper and a lower speed?
Oh, well, for the positive infinite, you use 20. Gives you exactly the same result. You can use 10 to the power of 99. But if you use 20 as the upper limit and an infinite, 20 is good enough. So if you do this normal CDF, enter, then you put 0.7143, comma, the upper limit is 20, comma, the mean is 0.69, comma, and the standard deviation is 0.0391, and that is equal to 0.2671 or something. But that's good, I mean, that's good enough. We are dealing with 5 in the 4th position, so it's good enough. I can accept that particular situation. Okay? It's 0.0004, the difference, so it's nothing. Okay? So when you use the calculator, it gives you 0.2671 instead of 0.2676, but it's not. It's exactly the same thing. Okay? So yeah, you can use your calculator. You have a TI-83. Who has a TI-83? Does the TI-83 also have this function, right? Yeah. Okay, good. That's it.
Can you explain that real quick one more time? I got lost there. How you get that?
This one?
Yes.
And this one. The problem asks you, what is the probability that when we select the 140 parents, between 96 and 105 parents from these samples are friends from their kids in Facebook. They want to know this range from 96 to 105. Okay? And remember, the proportion is equal to x divided by n. So we need to calculate the proportion for 96 is 0.6857. For 105 is 0.75. And then just, draw the distribution and find the probability between 96 and 105. So the probability that for that particular sample, between 96 and 105, the probability is 0.4813. Okay?